Images and vision. So when you think of a vision, what comes into your mind? Our eyes vision, you can see things. So they named something as images and vision, like Wanda and vision. OpenAPI named it as images and vision. And the subheading is learning how to understand or generate images. You can understand or generate images. You can do both actually, but yeah, just let's just go with what they say. Create images. Use GPT Image, which is a product. GPT Image is a product of OpenAI. Use GPT Image or DALL-E DALI to generate or edit images. The other one is process image inputs. Use our model's vision capability to analyze images. I don't know why people name this like model's vision capability. Like, why do I have to name it? Like, just say the model's name and like maybe when you have to like edit somewhere, you might need this vision. So note it down. You might need this vision somewhere where you have to like when you are developing. You might in this guide, you will learn about building applications involving images with Open AI API. If you know what you want to build, find your use cases below to get started. If you're not sure where to start, continue reading to get an overview. So, I am actually targeting the beginner market. So, I would like to get the overview first. So, I'm just going to click, skip this tour of image related, this wholesome tour of image related use cases. I'm just going to skip this. Recent language models can process image. Recent language models can process images inputs and analyze them. A capability known as vision. Okay, it's like why do you name something vision? Like it's just not there. With GPT Image 1, they can both analyze visual inputs and generate. Okay, with image GPT Image 1, they can both analyze visual inputs and create images. So yeah, it's pretty much simple. I guess you guys know what's happening here, right? The OpenAI API offers several endpoints to process images as input or generate them as output, enabling you to build powerful multimodal applications. So they have several endpoints, which basically they mean only these three. Maybe they forgot to add the other guys. Like there are several. Just go with the several. Analyze images and use them as input and or generate images as output. Okay, you can put it input and also or if you want output. Oh, you cannot. You don't want. Images API generate images as output, optionally using images as input. So you can give a text or you can input another image. Let's say you have your friend's face, the image, and you can add this as input and make him like a clone. I mean the Joker clone. Yeah, that you can do with the image API. Chat completion. I don't think you can do that actually, but I'm just giving an example for you to understand. Chat completions API. Basically, if you're creating a chat agent, you can use this chat completions API. Analyze images and use them as input, text or audio. Analyze images and use them as input or okay. I think these three are kind of saying the same thing, but with little subtle differentiation. Uh, Maybe we can analyze it. Like maybe we can now we can actually figure out so this guy you can analyze um responsibly analyze. I'll just put images as this. Analyze images, use them as input. Okay, it's this is the somewhere this this is our response API or generate images as output or generate. So these guys generated input. So let's say these guys, let's say this is also like this. Generate output. Should I use another color? Maybe yes, yes. Generate output. Let's color this back. Output. Optionally using images as input. Okay. Sometimes you use this. You know, yeah, analyze images. Okay. Like you just analyze images and use them as input. Okay. Again, input to generate text or audio. Okay. This is different. This is not generate text or audio. You can use. So it's a chat completion. So guess you can use that. Subtle difference. Only this is the major difference, I guess. Like, yeah. Let's move on. To learn more about the input and output modalities supported by our models, refer to model space. You can actually go to this page and refer to this, if you want to learn more about this. Generate or edit images. You can generate or edit images using the image API or the responses API. So I guess these both two are the main things. So they can actually, use to like, play with the images. Our not play exactly like modify the or generate images. Our latest image generation model, GPT Image 1, I guess this is the same. This is currently the latest as well, is a natively multi-modal large language model. It's a natively okay when they, when they put this natively, I think of Android Studio for some reason. Like, for Android development, the native development is using Android, not the Flutter or the React Native. Actually, React Native is not actually native. So when they are saying this is a natively multimodal language, that basically means uh, you can. There are other models as well, but this is a native multimodal language. This GPT Image 1. It can understand text and images and leverages broad world knowledge to generate the whatever that they got from the internet, the data that is going on. That's what they are like saying here. Like, if you're a marketing person, it's well, but if you're a beginner who wants to get into the IT, I don't think this helps. They're just talking about the data, man. To generate images with better instruction following. Okay, generate images with better instruction following and contextual awareness. In contrast, we also offer specialized generation models, DALI and 3, which don't have the same inherent understanding of the world as GPT image. So these are like kids. They don't have, not Gen Z kids, like if you're a, like, boomer kid, if you don't have the understanding of the world. I don't know why they like have these terms, like not in technical terms coming into a technical documentation is kind of weird. Like, hey, they don't understanding of the world, they don't understand the world, Dali and 2 3, they don't understand the world, they are at home all the time. So we have the, the example. You can, they have only two, they just wanted to go with two. They didn't bother with the, the Go and all the other languages as usual. So here you can see, it was client earlier. You can see there was clients in other example. They just, like this, the text generation, but they just, you know they just want to keep things simple. In the middle of the documentation, they realized, I just want to keep things simple, so they went with OpenAI. uh, OpenAI responses dot create. You pass in parameters, model, what's GPT 4.1 mini, and the input. Generate an image of gray tabby cat hugging an otter with an orange scarf. That's really weird, Gray tabby cat hugging an otter. That's kind of strange with an orange scarf. In the tools parameter, you should pass an array of objects which has a type which is called image generation. You get the response, save the image to file. Response has a property called output, and you're going to filter for that some reasons, like whatever the output that has the type of image generation call, and then you have to just get the result, and this will return an array of output dot result, which only has this one image generation call. I don't know, maybe the other, output has, output objects has something, types, several other types like metadata, I guess. So if the image data length is greater than 0, you get the first one. Image base 64, that is the base 64, I guess. And then you use the the file library. You create you know an image png from the buffer. You can learn more about the image generation in our image generation guide. You can actually, we'll come to that later. Using world knowledge for image generation. The difference between DALI models and GPT image is that a natively multimodal language can use its visual understanding of the world to generate lifelike images, including real life details, without a reference. For example, if you prompt GPT image to generate an image of a glass cabinet with the most popular semi precious stones, the model knows enough to select gemstones like amethyst, rose quartz, jade, etc. I don't know what these gemstones are. I know that's why I'm poor. So if you're a rich guy, you might know it. And depict them in a realistic way. So if you go and ask Dali, Dali is a kid. He doesn't know about these rich stuffs. I don't know about you know, I don't know about the gems as well. That make me Dali? No. But if you want something, Dali might have some use cases. It's not useless. Like I'm useless. No. Analyze images. Uh, Vision is the ability for a model to see and understand images. Eyes have vision. Same goes to the models. If the models can see and understand images, it has vision. You know, that's, you know, they give, they give the model the ability to have a vision. Not the vision that the leaders have, but the vision that you have, the eye vision. If there is a text in an image, the model can also understand the text. It can understand most visual elements. When they say most, that means like 99% of the time. I mean like 10% of the time, including objects, shapes, colors, and textures, even if there are some limitations. So they have mentioned two things: most, and there is limitations. We'll go back to that later. I guess we can. I think the limitations are below, so we will get there eventually. Uh, Giving a model images as input. Giving a model images as input. Okay, you can provide the images as input to generation requests in multiple ways by providing fully qualified URL to an image file. I'm not sure how a URL becomes fully qualified. Like, they have some qualification, maybe a degree. You know, if you want to provide an image file, that URL has to pass a degree. That's the qualification, I guess, or do some lead code. By providing an image as base64 encoded data URL, that makes sense, better than the fully qualified. By providing a file ID created with the files API, so you put your image into the file API, you get the file ID, you provide it to that. You can provide multiple images as input in a single request by including multiple images in a content array, but keep in mind, images count as tokens and will be billed accordingly. So they are middle class friendly also. So they are talking about these tokens. Hey, just keep in mind, man, tokens, images are tokens. Just because I say you can do this, don't do it. This is not only beginner friendly, tutorial or documentation. It's also middle class friendly tutorial. Uh, so there are two ways. If you are using the URL, um, you pass in the responses API. You just pass in. We are still using the responses API, not the image API. Just know that. Model GPT 4.1 mini. You input. You pass in the role, content, type. Then again the type. You just pass in the you know this, whatever this is, the board book. You know. Then you get the output. Pretty neat. Same thing, I guess. Uh, you get the image path. You pass in the image URL again. uh, Passing file ID, I guess. You can actually call it a file ID. You can get the file ID, create file. Um, yeah, you can do that. Pretty neat. What is this image? Image input requirements. Give me a second. Images input requirements. Input images must meet the following requirements to be used in the API. So there are limitations. Like when we are building a system, we have limitations. If I say to upload an image, don't upload PDF, right? So PNG, JPEG, WebB, non-animated GIF. If the GIF is animated, basically it has an anime. You're not good. You're not good. Size limits up to 50 MB. Total payload size per request, so only 50 MB, but up to 500 individual images input per request. That means within 50 MB, you can actually, probably like bytes 500 individual images, I guess. Other, I guess, because I don't clearly understand this, what they mean, like 500 individual images. How can I put 500 individual? Can you actually put 500 individual images within 50 MB? I don't know. Really, maybe it's mostly in KV, I guess. Yeah. Other requirements: no watermark logos, watermarks or logos, no NSFW content. That means don't send your nude pictures. Clear enough for a human to understand. That doesn't mean a human nude picture. Just clear enough for a human to understand. Okay, cool. Specify image input detail level. The detail parameter tells what level of detail to use when processing and understanding the image. Low, high, or auto to let the model decide. If you skip the parameter, model will use the auto. Of course, it can use the auto. So this is the type, image URL, the detail is high. You can save tokens and speed up responses by using detail low. This lets the model process the image with a budget of 85 tokens. The model receives low resolution 512 pixel into 512 pixel version of the image. So if you put a HD image, it's going to be reduced to 512 pixels because you put the detail as low, but it's budget friendly. This is fine if your case doesn't require the model to see high resolution detail. For example, if you're asking about the dominant shape or color in the image, that's very rare. Like I wouldn't upload like a documentation, like maybe a picture of someone with a cloth on and ask them like what's the shape and the color. I wouldn't do that. I would just see myself. On the other hand, you can use detail high if you want the model to have a better understanding of the image. Read more about calculating image processing costs in calculating section, which is actually below. We will go to that later. Limitations. So we are back to limitations where we left off. While models with vision capabilities are powerful and can be used in many situations, it's important to understand the limitation of these models. Here are some known limitations. Medical images. The model is not suitable for interpreting specialized medical images like CT scans and shouldn't be used for medical advice. So the doctors and the patients are out of clear. Doctors will have their jobs and the patient will have their life. Non English. The model may not perform optimally when handling images with text of non Latin alphabets. Okay, come on, like that's non English. Then you're saying this is non Latin alphabets, such as Japanese or Korean. Okay, I see something politics here. Like there is marketing here and there is politics here. Like why Japanese and Korean? Like it's non English. Every other language, other than the English, should be there. Okay, small text, enlarge text within the image to improve readability, but avoid cropping important details. Okay, you can enlarge it, but don't cut it. Okay, that's pretty much common sense. Just don't put small text and don't cut your cut. Ah, classic. Rotation. The model may misinterpret rotated or upside down text and images. So if you rotate your image and put it there, like it might consider you for an alien. Visual elements. The model may struggle to understand graphs or text where the colors or styles like solid dash or the dotted lines vary. Okay, I don't actually get this. You know, I don't really get that. So, visual models may struggle to understand the graphs or text where the colors or styles okay, like solid or dashed or dotted lines vary. Okay, so if there's a graph like this with you know like this and you know um, they might struggle to understand. Like if I ask hey, the give me what's the the rate of, I don't know, like something like that, it might not perform well. uh Spatial reasoning, the model struggles with tasks requiring precise spatial locations such as identifying chess positions. So if you put hey, if you have a the spy glasses and asking hey, what's the next move, where's the queen, sorry, where's the queen, by the way the queen is with the king, that's where the queen is, sorry, queen is. So don't ask spatial reasoning. Accuracy, the model may generate incorrect descriptions or captions in certain scenarios. Uh, Accuracy, the model may generate incorrect descriptions or captions in certain scenarios. So don't go and tell your the graphic designer that you have like, hey, you're fired. Hey, by the way, the captions are off. Can you fix it? Image shape. The model struggles with panoramic and fish eye images. It's not actually fish eye, yeah, fish eye. Fish eye basically means, I think, 360 view images, and don't give them the panoramic, which you cannot take properly with your iPhone or any other phone. Metadata and resizing. The model doesn't process original file names or metadata and images. Okay, metadata and resizing. The model doesn't process original images, file names, or metadata, and images are resized before analysis, affecting the original dimensions. Okay, so if you're giving the images, uh, so make sure that you're not having a task that involves the file name. Like let's say you give the model three images and you don't refer it by the image name or something like that, because the model doesn't process the original file name or image. And also make sure that the if you're giving an ht image, that might be reduced into another size because of the limits that the api has. uh, cool. Counting, the model may give approximate count for objects images, so just don't upload monkeys photos and ask like, hey, how many monkeys are there? Four, including you. Captchas, for safety reasons, our systems blocks the submissions of captchas. Don't put there, it's not, because captchas are for identifying AIs. Don't give AI the captchas. Calculating cost. Calculating cost. Images inputs are metered and charged in token just as inputs are. So hey, like don't say hey, text have tokens. You can just inputs, images are tokens. How images are converted to text tokens varies based on the model. You can find a vision pricing calculator. Okay, now you know why vision is there for, to put it in front of the pricing calculator, the FAQ sections of the pricing page. Uh, GPT 4 point mini, GPT 4 point, okay, why did that go there? Vibra Nano 04 mini. Images input are metered and charged in tokens based on their dimensions. The token cost of an image is determined as follows. Let's get our tools. Okay. Calculate the number of tether pixel. Okay. Let's put this there. A patch may extend beyond the image boundaries. Outer bounds are treated as well. So let's say you have this. This is the image, and there's something called patch. Let's say that's 32 pixel patch. So you will have like this. Sorry for my this. And if it is out of boundary, that will be treated as black. Okay, you get this right. These are patches, four patches, five patches actually. Uh, oh no, actually it's four. My bad. So row patches beyond. Okay, row patches ceiling width divided by 32. So this width is divided by 32. You'll get the row patches this side, and into height, same thing goes here. Cool. Uh, if the number of patches exceed 1536, we scale down the image so that it can be covered. If the number of patches, so we saw five patches earlier. Okay, five patches means 5 into 5, 25 patches earlier. Uh, but if it exceeds 1536, you have to scale down the image. It can be covered by no more than 536 pixel. So this just consider this as the ratio. This is the ratio that this will be sized down. This is that formula. Just just memorize this if you want, but like this is the formula. So you take this, you flow same similar to something calculation. You know the minimum, you take the minimum of this or this, whatever the minimum, you take it, and again add it to the previous ratio. I guess you will get the final ratio. The token cost is the number of patches capped at a maximum of 1536. You already told this. Why I be having this again? Okay, okay. Capped at the maximum. Okay, the token cost. So you said this earlier. Then this came. You scale down. Then after you scaling it down, you again see whether this is maximum capped, and then you'll get the image tokens. Apply multiply based on the model to get the total token. Okay, total token. Mm-hmm. Mm-hmm. Okay. We have. I don't know why this multiple. Okay, total token. This is the image token, and you add this multiplier, and then you'll get the final token, I guess. Uh, yeah. Cost calculations. 1024 into 1024 is 1024 tokens. Width is 1024, resulting in 1024 plus 32 minus 1 is equal to 32. 32 patches. Okay. If you have a thousand, 1024. Okay. 1024 1024, you will get actually, according to this calculation, this will be 32 patches, like this 32 patches, and here also you will get 32 patches. Fine. Then you will multiply 32 into 32, you will get again 1024, which is below the cap. So the total tokens will be 1024. So again, you have image equals 1800 into 20 2400, which is image is 14,052 tokens. You have this calculation again. 1800, you'll get 57 patches, 75 patches, 47,000. Then you have to scale it down. You will get this ratio 0.603. Then you will add that up here, I guess. Then you will get this patches, and we want to make sure the whole number in this case again by this divided by this in equal to 0.97 to fit the width in 33 patches. Final is then 1056 1408. That will be the final, I guess. No, that's not the final. Image requires divided by 32 33 patches to cover the width, and this to height and width you get here. The total number of tokens is this, below the cap of 1536. That's pretty cool. So these are the limitation of what you call these guys, right? Input images. These images have that limitation. GPT, okay, there's another thing. GPT 4.0, GPT 4.1, GPT 4.0 mini, CUA and O series except zero point 0.4 mini. The token cost of an image is determined by two factors: size and detail. Any image with detail low costs a set of base number of tokens. This is the amount varies. This amount varies based on model. See chart below. To calculate the cost of an image detail high, we do the following: scale to fit 24 pixels square, maintaining the aspect ratio. Okay, So you will have something called this square. 20, that's a square, supposed to be a square, but it didn't come. So what are the images that should fix within this square? If it doesn't, I think you have to again scale it down. And after, if this fit it, so that the image shortest side is 768 pixel long. So if that fix, the shortest side should be 768 pixel. If it's not, you have to, like, let's say the aspect ratio was 4 is to 3, then you have to reduce it, right? So the shortest side has to be 768 pixel. Count the number of 512 pixel squares in the image. Each square costs a set of amount of tokens. Okay, again, this 512 blocks, 512 pixel squares, basically this. How much? Basically, let's call it patch again. Like, then you will get the amount of tokens, and then you have to add the base tokens to the total. So here the base tokens are 70. So if you are using detail low, you will get these, and if you are using uh, you know tile tokens for one square block, one tile, uh, you will have 140 tokens. So the more the tile you have, you will, like, let's, if you have two tiles, you will have 280 tile tokens as tile tokens. Cost calculation example, GPT 40, 1024 in image, detail 0, made cost 7, mode cost 765 tokens, 1024 is less than 2048, so there is no initial resize. Okay, there's no resize. Total side of 1024, we can scale the image down to 768 into 768. Okay, you have to scale it as I said it earlier. I think 1025 means it's 1 is to 1, so 768 into 768. 4, actually, they should have, like, somebody might read this as 4512, but just put the 4, like, 4 512 pixel square. That's what they are meaning here. 4 512 pixel square tiles are needed to represent the image. So the final token cost is 170 into 40. This 170 into 40 plus 85, the base token, is equal to 765. Same goes for this. So this is bigger. You have to scale down the images to fit within 2048. Then you this thing 768 with the the aspect ratio. Then there will be 6512 pixel square needed, so the total will be this. The same goes if it is a low token. There is no this calculation. It will just get this. The base tokens will be regardless of the input size. The low detail images are at a fixed cost, which is the base token. GPT image 1. These are other model. This is another model. GPT image 1, as I said earlier, this is another entirely different model. For GPT image 1, we calculate the cost of an image input the same way as described above, except that we scale down the image so that the shorter side is 512 pixel instead of 760 pixel. Okay, the same way, but the only difference is 512 pixel. The price depends on the dimensions of the images and the input fidelity. I'm not sure what the fidelity means, but I think it's kind of similar to the quality or the way it gets rendered. When input fidelity is set to low, when input fidelity is set to low, the base cost is 65 image tokens. Okay, it's set to low. The base cost is 65 image tokens, and each tile costs 129 image tokens. When using high input fidelity, we add a set of number of tokens based on the image's aspect ratio in addition to the image tokens described above. If your image is square, we add 460 extra input image tokens. If it closer to portrait or landscape, we add 600 240 extra tokens. This is kind of similar to the same calculations. We are just having different numbers here. To see pricing for image input tokens, refer to our pricing pages. It is a different model. I think this is better, in some ways, I guess, but I'm not sure how. Like, because I don't know much. I don't understand the basic difference between the GPT-1 image and the other guys. We process images at a token level, so each image we process counts towards your token per minute limit. For the most precise and up-to-date estimate for image processing, please use our image pricing calculator available here. So if you want to particularly analyze what's your company's monitoring cost is going to be. Be aware of it. Yeah. So see you on the next one.